Hi, so today we're going to be talking about the chapter 8.3, describing and analyzing data from our textbook. It'll be a little bit longer of a video because there's quite a few things to keep in mind, but I'll try to make it as short as possible. This is my second time recording this because last time I did, it had no audio, which probably was fine because now I get a new chance to be more brief. So to start, there are a few concepts that you've probably learned in elementary school, and one of that would be mean, median, and mode, and also range. There's 4 concepts. So means are averages. So before, I'll give a sample data set. So 1, 2, 3, 4, 5, 5. A mean is the average. To calculate a mean, you will add all of them up together. So we'd add 1 plus 2 plus 3 plus 4 plus 5 plus 5. And then we would divide them by how many numbers. We divide all of that by how many numbers we have. So 1, 2, 3, 4, 5, 6. We have 6 numbers. So we'd be dividing by 6. The median, one second. The median is the middle. So 1, so 5, 5, and 2. So we have 2 medians here. When you have 2 medians, 2 middle points, you're going to add them together. So 3 plus 4, and then divide them by 2, which will give you 3.5. If we were missing this 5, then our median would just be 3. But since we have that 5, it's going to be 3.5. Sorry. The mode is any numbers that repeat. So in this example, we have 2 5s. So our mode would be 5. You can have more than one mode. So if you had an extra 3, you could have a bi-mode. It would be bimodal. So there's 5 and then there's 2 3s. And you can have, so this is unimodal when there's only one mode. Then there's bimodal when there's 2. Then there's multimodal when there's more than 2, and then there's sometimes no modes. So if there was no 5 here, then there would be no mode. A range is the highest data point minus the lowest data point. So in this case, it would be 5 minus 1. So our range would be 4. So those are some concepts. Another is the idea of our bell graph, our bell chart, our bell curve. So we have this middle point here is our mean, our average. And we'll be learning about the concept, in this video we'll be learning about the concept, of a standard deviation. And, we will be, but the empirical rule. And you will need to memorize at least 3 values from the empirical rule for the test. I'm pretty sure, not 100% sure, but I'm pretty sure that it will probably be on the test. And so we'll go over that really quick. So these 2 here, 1 standard deviation away from the mean on both sides, 68% of our data is going to lie in this quadrant. Within 2 standard deviations, 95% of our data will lie here. Let me move this down a bit. And then within 3, 99.7% of our data lies here. Now, if you memorize these 3 numbers, 99.7, 95%, and 68%, and which quadrants they align to, finding the individual ones should be easy. So if 68% of our data lies between these 2 and they're equally distributed, that means that 34, we can divide this by 2 because it's equal. 34 is in each of these because 34 plus 34 is equal to 68. So 34% lies in this one, 34% lies in this one. If we take 95 and minus this 68 from this middle here, we'll get 27. So in this quadrant and this quadrant combined, we have 27%. if we divide it by 2, we can get this individual one, which I believe is 13.5. Then if we did the same except for with 99.7, so 99.7 minus 95, I believe you should get 4.7. So these will be 2.35 and 2.35%. And then the rest of the graph is 100%. So if we take the 99.7 and subtract that from 100, we get a remaining 0.3%. And if we divide that by 2, we get 0.15% for these individually. And this is important in some of the equations because it will be asking you occasionally, using the empirical rule, what percentage of data points fall like in this range. And sometimes it will give you weird ranges. And then there's the idea of a standard deviation. Now, give me 1 second. I'll draw something up really quick. So let's say we have 2 factories that make toys, and they have a quality scale rating for each of the toys made, and 1 through 10. And 1 means the toy was not made very well, and 10 means the toy was made perfectly. Let's say we have a factory that makes. We have 2 different factories, and they both make toys, and they both abide by this quality scale. This factory here has 6 toys that have 5 quality, 2 toys that have 4 quality, and 2 toys that have 6 quality. This factory here has 4 toys that have 5 quality. And I switched those accidentally. Anyway, 4 toys that have 5 quality, 2 toys that have 4 and 6 quality, and then 1 toy that has 7 and 1 toy that has 3 quality. Sorry for switching those up. The standard deviation is going to, the standard deviation is a way to describe this basically. A low standard deviation, this right here has a low standard deviation, and this one right here has a high standard deviation. Standard deviation basically is a way to describe that. It shows how widely spread the data is. There's ways to calculate this by hand or with calculators, but I prefer using Excel spreadsheets. If you recall, when we were talking about statistics earlier in the unit, we talked about the terms population and samples. When you are calculating the standard deviation, you need to be aware of whether you're calculating a standard deviation of a sample or a population, and it'll either tell you explicitly that you're looking at a sample, or it will hint at things like a sample or a population. Sample, for a recap, a population is pretty much all of the data points that you could have. For example, like all American citizens. A sample is just like a subset of that. So I could say 500 American citizens. So if we're doing a sample, you'll type in Excel equals stdev.s for sample and .p for population, and it will give you a parentheses to fill, and you'll paste in all of your data points that you have. Make sure you have commas in between each of them, and then close your parentheses, and that will give you the standard deviation based on your population or based on your sample. I believe that covers all of the general stuff. I will hop into examples in just a moment, but I want to go into one example first that caught me off guard when I was doing this. It's this one that was the preferred floor plan of an apartment amongst several apartments with the same square footage. We're considering this data set, and we're wondering whether we'd be more interested looking at the mean, median, or mode, and we want to state our reasoning. Now, the preferred floor plan is not a number. It's not something you can find the average of. It's not something you can find the median of. And it caught me off guard because I didn't think you could find the mode of it. But you probably could have two people who want the same floor plans. So I chose, so the answer, I didn't choose mode. But the reason why it's mode is because you can have data that is not measurable with modes. So that would be your two things. Anyways, that was already lengthy. We're at 10 minutes. If you were here just for the information, you're free to go. I'm just going to work through some of these example problems because I know that a lot of this is a little bit tricky, especially since a lot of it is dealing with math language instead of just English. But I think that if you break it down into English, things get a lot easier to deal with. So this one is telling us that the diameters of a new species of apple have a bell-shaped distribution with a mean of 7.25 centimeters and a standard deviation, which is shown by this weird little sign, of 0.42 centimeters. And we want to use the empirical rule to figure out what percentage of apples have a diameters that are greater than 8.09 centimeters. So when it says using the empirical rule, we can probably assume that this data point that it's trying to get us to is an even amount, not even, but like a nice amount of standard deviations. It's not going to be like a percentage. So 7.25, if you add 0.42 to it twice, you should get 8.09. So 2 standard deviations away from the mean is our 8.09. And we want to find the percentage that has greater than this one. Now, if you recall with our graph, we already did this work. So here's 1 standard deviation, here's 2. We're within 2. So we're just going to add these 2 together. So 2.35 plus 0.15. And that should give you 3.50. 3.50%. That would be our answer. This one is giving us a range of the following data set, and we're assuming it's a sample. And I think that I got rid of, the range, my bad, I misread. Sometimes that throws me off. So range, we want to find our largest value and our lowest value. So 68 looks like it's our largest here, and our lowest looks like 34, nope, 30, just 30. So we can take 68 minus 30, and that will give you our range, which should be 38, yeah. So that's our range. This one is asking us to identify whether this data set is unimodal, bimodal, multimodal, or no mode. I always start saying it with an L. We want to assume it's a sample, and we want to find the modes, if any exist. So unimodal, if you think about bikes, unicycles have 1 wheel, bicycles have 2 wheels, and multimodal, like multicycles, I don't think those exist, but they probably have more than 2 wheels. So we want to look through this, and it looks like there's 3 29s, but I'm not catching any other repeats. So our answer would be unimodal, and it would be 29. This next one is another empirical rule question where our mean is 98, and we have a standard deviation of 13. We want to use the empirical rule to find what percentage of IQ scores are between 85 and 111. If you take 98 and minus 13 from it, you get 85. So that's 1 standard deviation away. And if you take 98 and add 13 to it, you should get, sorry, I don't remember which one was my mean, which line it was. But anyway, you get 111. So 111. So they're both 1 standard deviation away. And we want to know what is between. So between 85. So this part right here. And that actually is easy. If we look back here, we know that within 1 standard deviation, it's going to be 68%. So our answer here is going to be 68%. This next question is the most tricky thing about it is that it's giving you this really daunting equation, but really it's not anything different than what we've seen so far. And honestly, you've been learning stuff like averages since like 4th grade. It's just giving you the math language of this instead of the English language of it. So it gives us our first 4 test grades. He has one more test grade, but we don't know what it is, and we know that his average is 90.2. To find an average, which we already know the average, we have to add all of our numbers up. So 86 plus 95 plus 98 plus 88, and then plus our unknown test score, which we'll label X, and then divide by however many values we have, which is 5. Then we want to solve for X, which if you times 90.2 by 5, so 90.2 times 5, and then you minus this, you should get your answer. I won't do that for the sake of time. This video is already probably long enough. We already talked about the mode one. This one is another type of question where we are determining the certain data set, and we want to know whether looking at the average, the mean, median, or mode is most effective. So it's saying the number of tickets sold by a band on a single tour if they primarily played small venues and only one show in a large arena. So we want to know whether we'd be interested in looking mean, medium, or mode. So it's giving us an outlier. He does one show in a large arena. That would probably throw off of our data. So we probably don't want mean. We probably don't care about mode because it's, number one, it's unlikely that he sells the same amount of tickets in more than one. But also, even if it happened, it wouldn't really be useful. So it's going to be median. And we know that it has outliers, so the data has measurable values with outliers. This is another empirical value question, but I believe we've covered those enough. And this one is asking us for the standard deviation. In Hawks, you can copy the data like this and then paste it into Excel. And this one tells us that it's a sample, so we do the sdev dot s, and then paste those in, or put them into cells and grab a range. So I know that video took a long time. If you have any questions, please let me know, and I will happily answer them. I know that this covers a lot of kind of wonky stuff that isn't very intuitive. So yeah, have a good one.